Good afternoon, everyone. I am Nishu Sharma, HOD of Mechanical Engineering Automobile, Department of Mechanical Engineering of IIMT College of Polytechnic, Greater Noida. Today, we will discuss about the CAM and before going to start, firstly, we discuss about the content of this session. That is the definition of CAM, classification of CAM, follower, and their classification, brief description of different types of CAM, and follower with simple line diagram, simple CAM profile for uniform velocity. So firstly, we will discuss about the definition of CAM, or we can say that what is the CAM. So basically, a cam is a rotating machine element which gives reciprocating or oscillating motion to another element known as a slider. And we know that what is the reciprocating? And reciprocating is just a motion, just sliding motion, like that up and down motion, right and left motion. That is the reciprocating motion, and oscillating motion is like as a pendulum motion, and the cam and the follower have a line contact and constitute a higher pair. So we in the which is firstly we will discuss the kinematic pair, and kinematic pair is a pair in which when the two links are joined in such a way that we have a constrained motion, and it is a completely constrained motion, or we can say that the motion in a definite direction. And the pair is classified into two types according to the surface contact, that is the higher pair and the lower pair. And the lower pair, we have a surface contact between a two link, and in a higher pair we have a line or point contact between the two links, and in a cam and follower there is a line contact and point contact between a cam and follower, so it make a higher pair. Or we can say that the application of cam is used for operating the inlet and or the exhaust valve of internal combustion engine, or we can say that timing of the inlet and exhaust valve of the IC engine, and attachment of machinery, paper cutting machine, automatic attachment, and the spinning and weaving textile machinery, feed mechanism of automatic lathe. And we can say that basically it is used for the timing of any machine. It uses a cam. Now we will discuss the classification of follower. There are a classification of follower according to a three type. Firstly, we have a according to the surface in contact, and then according to the motion of the follower, and last one is the according to the path of motion of the follower. So firstly, we will discuss the according to the surface in contact, and according to the name, that is surface in contact. It means when there is a contact between a cam and follower, so what does surfaces occur? That is according to the surface in contact. So firstly, it is a knife edge follower, and in a knife edge follower, the contacted end of the follower has a sharp knife edge. It is called a knife edge follower. In this diagram, we see that the A diagram is a cam with a knife edge follower. In this, we see that there is a follower and cam surface. There is a sharp knife edge, then it is called a knife edge follower. And in a knife edge follower, the sliding motion take place between the contacting surface, or we can say that the knife edge and the cam surface. It is used in a sometimes because the small area of the contacting surface result in excessive wear, because wear is inversely proportional to the area. So there is a surfacing area is small, so there is a excessive wear will occur. In knife edge follower, a considerable side thrust exists between a follower and the guide. Now, second one is the roller follower, and the roller follower is the when the contacting end of the follower is roller, that is called the roller follower. In this diagram, we see that the B diagram, that is the cam with roller follower. In this diagram, we see that the contacting end is the roller, so it is called the roller follower, and the rolling motion takes place between the contacting surface, that is the roller, and the cam. Therefore, the rate of wear is greatly reduced because there is a large surface area is occur. So the wear is reduced because we have also discussed that the wear is inversely proportional to the area. Now, next is the flat face or mushroom follower, and in a flat face or mushroom follower, when the contacting end of the follower is a perfectly flat face, that it is called a flat face follower. And in this diagram, in the C diagram, we see that it is a flat face follower, in which we see that there is a contacting end is the flat face, so it is called the flat face follower. And we see that there is the side thrust between the follower and guide is much reduced in case of a flat face follower, and the only side thrust is occurred due to the friction is between the contact surface and the follower of the cam. And the relative motion between the surface is largely of sliding nature, but wear may be reduced by offsetting of the axis of follower. But when a flat face, this face, when the flat face is follower of the follower is circular, then this flat face is converted into the mushroom follower. Now, next is the spherical face follower. In a spherical face follower, that is when the contacting end of the follower is of spherical shape, then it is called a spherical face follower. In this diagram, we see that D diagram shows the spherical face follower, and according to the definition, and in this the end of the follower is of spherical shape, so it is called a spherical face follower. And it may see that when a flat face follower is used as mainly in automobile engine, but there is a high surface stresses are produced. In order to minimize this stress, the flat end of the machine is to be spherical shape. Okay, and it is all about the according to the surface in contact, the classification of follower. Now we will discuss the classification of follower according to the motion of the follower. Okay, so the follower according to its motion are of two types. First one is the reciprocating or translating follower, and second one is the oscillating or rotating follower. Okay, so reciprocating or translating follower, when the follower reciprocate in guides as the cam rotates uniformly, it is known as reciprocating or translating follower. In this diagram, we see that A to D, that is in a diagram we see that cam with 9-phase follower, and a B diagram cam with roller follower, and in C diagram cam with flat face follower, and the D is the cam with the spherical face follower is the is of the reciprocating or translating follower, because in this we see that the follower reciprocate in cams. When the cams is uniformly rotated, then the follower reciprocates. Okay, and the next one is the according to the motion of the follower, that is the oscillating or rotating follower. When in the oscillating or rotating follower, the uniform rotary motion of cam is converted into the predetermined oscillating motion of the follower. It is called as the oscillating or rotating follower. So in this diagram, in a E diagram, we see that cam with spherical face follower. In we see that when the cam is rotated, then the follower is oscillated. So it is called as a oscillating follower or rotating follower. Okay, now third classification is according to the path of motion of the follower. So according to the path of motion of the follower, so basically follower are of two types. First one is the radial follower and second one is the offset follower. So radial follower is that when the motion of the follower is along an axis passing through the center of cam, it is known as the radial follower. And this diagram we see that there is A to E, that is the radial follower, and this is the cam with knife edge follower, cam with the radial roller follower, cam with flat face follower, cam with spherical face, and cam with spherical face. A to E diagram is shown as the radial follower, and in this diagram we see that the center line of the cam and the axis of the follower is same, so it is called as the radial follower. Okay, now second one is, it is the offset follower. When the motion of the follower is along an axis away from the axis of cam center, it is called as the offset follower. The follower as shown in diagram, that is the diagram F, is the cam with offset follower. In this diagram, we see that according to the name offset, offset means there is a distance between. That is the offset, and in the offset follower, the center line of the cam and the axis of the follower is not same. There is a distance apart. So that is called the offset follower. And in the diagram F, we see that there is a center line of cam and the axis of follower, there is a distance, and this distance is called offset. So it is the offset follower. Okay, now the classification of follower is finished. Now we will discuss the classification of cam. Basically, there are two types of a cam. The first one is the radial or disc cam, and another one is the cylindrical cam. Okay, so firstly we will discuss the radial or disc cam. In a radial cam, the follower reciprocates or oscillates in a direction perpendicular to the cam axis. Okay, and this is the example of this is example of the radial or disc cam, because in the diagram we see that the follower reciprocate or oscillate in a direction perpendicular to the cam axis, because this is a cam axis and the motion of the follower is perpendicular to this axis. That is, the cam axis is the x-axis, and in the diagram we see that the cam axis is the x-axis and the motion of the follower is in a y-axis, and we know that y-axis is always perpendicular to the x-axis, and it's also definition of the radial or disc cam is the motion of the follower is direction perpendicular to the cam axis. Okay, now next is the cylindrical cam. In a cylindrical cam, the follower reciprocates or oscillates in a direction parallel to the cam axis, and the follower rides in a group at this. This means in this diagram, we see that this is the example of the cylindrical cam. In this diagram, we see that the motion of the follower is parallel to the cam axis, because in this diagram we see that the cam axis is the x-axis and the motion of the follower is also in x-axis. The motion of the follower is shown by the arrow in this diagram. So we see this in the diagram, the axis of the arrow and the axis of the follower is in the x-axis. Okay, and the red dotted line is shown the axis of the cam. So in a cylindrical cam, the motion of the follower is always parallel to the axis of the cam, and the cylindrical group with a reciprocating and oscillating follower is the example of a cylindrical cam. It is all about the classification of cam. Now we will discuss the term used in radial cams. Okay, so basically it is also we call as a terminology of radial cam. And this diagram we see that there are different points and different terms, that is the pitch circle, pitch point, pitch curve, cam profile, prime circle, base circle, pitch point, maximum pressure angle, trace point, and total follow through. It is all about the terms of the radial cam, and we will discuss it one by one. Okay, so firstly is the first term used in is the base circle. Base circle is basically, it is the smallest circle that can be drawn to the cam profile. This is the base circle in this diagram. Smallest circle. This one. This is smallest circle of the of the cam, that is called the base circle. And firstly, we will draw the base circle for constructing the profile of the cam. Okay. Now, the second one is the trace point. Trace point is basically a, this is called, in this diagram, we see that this is called the trace point. This are look like that arc is the trace point, and trace point is the reference point on the follower, and it is generate to the pitch curve. Okay, basically a pitch curve is drawn through the trace point, but in case of a knife edge follower, the knife edge follower, they represent the trace point and the pitch curve correspond to the cam profile. We can say that in knife edge follower, trace point and the pitch point is the same. But in a roller follower, the pitch curve and the trace point is not a same, and in a roller follower, the center of cam represent a trace point. Okay. In this diagram, we see that this is a roller follower. There is a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This is called the trace point. Okay. Now, next is the pressure angle, which is very important term in a radial cam. It is the angle between the direction of the follower motion. In this diagram, we see that this is the maximum pressure angle, and it is the angle between the direction of the follower motion and the normal to the pitch curve. And this angle is very important to designing a cam profile. Okay, we see that it is the direction of follower motion and the normal to the pitch curve. This angle make a pressure angle, and if the pressure angle is very large, then the reciprocating follower will jam in its bearing. Okay, next is the pitch point. Okay, so pitch point, in this diagram we see that this is the pitch point, and pitch point is nothing, it is a point on the pitch curve having the its maximum pressure angle. Okay, pitch point is that point at which the at which we have a maximum pressure angle. Okay, now next is the pitch circle. Pitch circle is that this is the pitch circle, this one, and the red dotted line, this is the pitch circle, and this is circle drawn from the center of cam through the pitch points. It is called the pitch circle. Okay, now next is the pitch curve. Pitch curve is it is a curve generated by the trace point as the follower move relative to the cam. For a knife edge follower, the pitch curve and the cam profile is same, which we have also discussed. And whereas for a roller follower, they are separated by the radius of the roller, because in a knife edge follower, the trace point, or we can say that pitch point is the same, and but roller follower is not. Okay, and next is the prime circle. Prime circle, this is, and prime circle is not made in all the follower. It is only made in a roller follower. Okay, this one is called prime circle, but it is only generated in a roller follower. Okay, and prime circle is it is the smallest circle that can be drawn from the center of cam. Okay, and tangent to the pitch curve. For a knife edge follower and a flat face follower, the prime circle is the base circle, And so I have also discussed that the prime circle is not in all the follower, but only in a ruler follower it is generated. So we can say that for a knife edge follower and a flat face follower, the prime circle and the base circle are identical, or we can say that same. And for a roller follower, the prime circle is larger than the base circle by the radius. Okay, now next term is the next term and the last term is the lift or stroke. This is the total follower travel is it is the lift or stop, or it is the maximum travel of the follower from its lowest position to the topmost position. Okay, it is called the lift or stroke. It is all about the terminology of the radial cam, or we can say that term used in the radial cam. Now we will discuss the motion of the follower, which is very important because the construct of the cam profile. Firstly, we know that what is the motion of the follower. According to the motion of the follower, cam profile are drawn. There are basically a four motion of the follower, and for construct the cam profile, they have made one of the following motion. Okay, first one is the uniform velocity, uniform acceleration, retardation, simple harmonic motion, cycloidal motion. And okay, now and for doing the construct cam profile, firstly we draw the displacement diagram, velocity diagram, and acceleration diagram. And for making a cam profile, construct the cam profile, we only use the displacement diagram. And for drawing the displacement diagram, there is a displacement, velocity, and acceleration diagram. When the follower moves with uniform velocity, there is a case. There in the case we will take a first case, that is a uniform velocity. And for uniform velocity, there is the displacement diagram. And for drawing a displacement diagram, there is we use as a displacement, velocity, and acceleration diagram when a knife edge follower moves with uniform velocity, which is shown in the diagram A, B, C. Okay, and there is for doing the making the diagram, we use a x-axis and the y-axis. And in the x-axis, or we can axis base represent the time, that is the number of seconds required for the cam to complete one revolution, or it may represent the angular displacement of cam in degree. The ordinate that represent, that is the y-axis. Abscissa means base means x-axis, and ordinate means the y-axis represent the displacement, velocity, or acceleration of the follower. In this diagram, we see that there is a diagram between a angular displacement and the displacement, and this is the and y-axis we use the velocity, acceleration of the follower, and in this y-axis we use the stroke or lift of the follower, that is the minimum position to the max. There is a travel between a minimum position to the maximum position. In this case, we see that in the diagram there is a rise, dwell, return, dwell. It is the one revolution of the cam. Okay, and we know that the one revolution of cam is the 360 degree. And in this, we see that the rise is the when the cam a follower moves from with the position lower position to the maximum position. It is called rise, and it is also called as the out stroke position. Okay, and in a dwell there is no motion occur, and in this position we see that in a rise, in out stroke position, follower moves from A point. A point is the lowest position, and the maximum position is the B1. And in out to stroke position, we follower moves from A to B1. That is the maximum position. And in a dwell, there is no follower motion. Then V1 and C1 is the same point. There is the only time is occur, but follower there is no motion of follower. And at the C1 there is the return. Return is also called as a fall of the follower, and return stock, or we can say that, and in which a follower moves with the highest position to the lowest position, then it is called the C1 to the D. Then again dual, there is no motion occur. So there is the A to E. There is the 360 degree uh, of the 360 degree, and it is also called as the one regulation of the cam. It is a diagram basically of a uniform velocity, and we know that there is a velocity of uniform velocity, and there is a diagram of the is a simple rectangle, and in a dual position there is no motion occur, so there is only zero. And in the return, there is return stock, there is a return to its lowest position, and it is the negative direction. And for we see that at a point, starting point, there is a time is zero, and we know that acceleration is the rate of change of velocity with respect to time. And when the time is zero, then we get acceleration value is infinite, and we see that infinite value. And we avoiding the infinite value, we take a sharp edges of for this, we take a curve of this, and we diagram, we say that the we see the curve this position, and we get a some amount of acceleration. Okay, so it is all about the displacement diagram of the cam when it is moved with a uniform velocity. Okay, thank you.